All right, so we're talking section 7-2 today, which is similar polygons. Now, before break, we talked about ratios and proportions. Those are going to be key in this lesson. So we start off with vocabulary like we always do. That vocabulary being similar polygons. So similar polygons are two or more polygons. Would help if I use the pen tool probably. There we go. Two or more polygons which are the same size, but not necessarily the same shape. Okay, so what we're saying is they're definitely the same shape, but one may be bigger than the other or smaller than the other. What we mean by same size but different shape, or same shape, I said that the wrong way. Same shape, and it should be shape in the first blank, size in the second. This is me being nervous about being a virtual teacher and screwing stuff up already. All right, let's do that again. Same shape, but not necessarily the same size. Good thing I caught that. That would have been very confusing. All right, so what we're saying here is that in order to guarantee the same shape, the angle pairs are congruent, just like they were for congruent polygons. Okay, so you'll notice the markings in the picture. Each angle in ABCD is paired with an angle in EFGH. Okay, we've got angle A is congruent to angle E. And we know that based on this similarity statement because A and E are the first letters in those names. Guess I should probably mention that this symbol here is the symbol for similar. That's squiggly. The tilde is the similar symbol. Okay, that tells us that A is congruent to E. We'll notice those are marked with one mark each in the picture. Angle B is congruent to angle F. Again, that's the second letter in each name. Angle C is congruent to angle G. And angle D is congruent to angle H. Okay, the angle pairs, those are congruent. And it's just like a congruence statement. They have to line up name to name. So the first letter, the first letter. The second letter and the second letter. The third letter and the third letter. Tell us which angles are congruent to each other. Then we've got the sides. Well, the sides, we're not guaranteeing that they're the same size. So the sides are not congruent. The sides are proportional. So what I mean by that is that all four sets of sides are proportional to each other. So, in other words, AB, which is the first two letters in the first name, over EF is equal to BC, which is the second and third letters, over FG, second and third letters, is equal to CD, which are the last two letters, over GH, is equal to the first and last letters, AD, over first and last letters, EH. The sides are not congruent. They are proportional. And again, that's the same sort of thing we did with congruent statements in terms of pairing stuff up. First two letters over first two letters equals second two letters over second two letters equals last two letters over last two letters equals first and last over first and last. Now, when we actually use that in a problem, we won't use all four. We'll only use two at a time because you can't solve a proportion if it consists of more than two ratios. But all four of those ratios are equal to each other. They are proportional. So that's the basic background information for what we're going to get through today. We're going to do 3 more slides, assuming that time holds out here. We've got about 20 minutes left to get through that stuff. So, any questions before we continue? All right. So the first problem type you're going to see is going to look like this example here. It's going to say, it's going to give you a similarity statement. So in this case, if triangle FGH is similar to triangle JKL, list all pairs of congruent angles and a proportion which relates the corresponding sides. So notice that they gave us a similarity statement. So the first set of angles would be the first letter in each name. In other words, we can state from the similarity statement that angle F is congruent to angle J. And we can even mark that in our picture, one arc for each of those angles. Okay, those are the first letter in each name, so they must be congruent to each other. Same for the middle letters in each name. Angle G is congruent to angle K because those come second in the similarity statement. So we'd give those two arcs, G and K, in our picture. And then finally, our third set of angles is the last letters in each name, H. Angle H is congruent to angle L, which would get 3 marks in our picture. Now, the main reason to draw a picture is to help us set up the proportion, because we're all pretty good at matching up the angles. We've proven that on various vocabulary quizzes. The sides tend to give us a little bit more trouble. So for the side proportion, we would do first two letters, FG over JK, equals the second two letters, GH and KL, GH over KL, equals the first and last letters. So FH for the first triangle over JL for the second triangle. Since these are triangles and they have 3 sides, our proportion should have 3 fractions. Notice that the side lengths of one triangle are on top of those fractions. Side lengths of the other triangle are on the bottom. And they match. FG is the first 2 letters in the first triangle. KL, or JK, sorry, JK are the first 2 letters in the second triangle. So that's the first problem type. We'll be taking a similarity statement, writing out the angle congruence statements and the side proportion. Any questions before we continue to the next slide?
Can you leave it on for a minute?
Sure. Let me know when you're ready. And the other thing I can do is when we get done, I'm happy to put any of these slides back up.
I'm done.
Okay, is everybody ready to move on? Okay, so the next little bit of information involves the proportion itself. If our 2 polygons are similar, then we've already said their sets of corresponding sides are going to be proportional. In other words, they're going to form that extended proportion. As it turns out, all 4 ratios in that proportion are equal to the same simplified ratio. And this is a term you probably heard in middle school. That simplified ratio is called the scale factor. So for instance, here in this picture, we have ABCD is similar to EFGH. So we should be able to set up the proportion AB is to EF, that's the first 2 letters in each name, is to BC over FG, it's the second and third letters in each name, equals CD over GH, that's the third and fourth letters in each name, equals the first and last letters AD over EH. This is the proportion that that similarity statement says is true. So what we're going to do is we're going to plug in the side lengths from the picture into that proportion. For instance, AB is 9. So we're going to put 9 in for AB. EF is 15. BC is 3. FG is 5. CD is 9. GH is 15. AD is 3. EH is 5. So we plug in the side lengths from the picture into the proportion. Notice that all four of those fractions are equal. Technically, 9 over 15 needs to be reduced. Those are both divisible by 3. But if we reduce them, notice that all four of those fractions, they're all equal to 3/5. So that simplified ratio, that reduced ratio of 3 to 5, that is our scale factor. Okay, so our scale factor and keep in mind this is ABCD to EFGH is 3 to 5. Now, the reason why I added the part in parentheses is because technically, and I don't think it's going to happen all that often, there are really two different scale factors. We've got the scale factor of ABCD to EFGH, which is 3/5. And that's the one that we would probably be using in this problem because our similarity statement has ABCD first, which means those would go on top. But in theory, we could also state that the scale factor of EFGH to ABCD would be 5 to 3. So it is technically possible that the wording in the problem could make the problem harder, but if it doesn't specify which shape should be first, then you're just going to give me the one based on the similarity statement, which would mean putting the sides of the first shape listed in the similarity statement on top. So that's a bit, there's a bit to write down there, so we're going to leave that up for a second. Does anybody have any questions while we get what we need off the screen? Again, the big thing here being that we can reduce all four fractions to the same fraction, and that fraction is our scale factor. Does anybody need more time before we advance to the last slide of the day? Okay, if you need me to come back to this after the lesson, I can. It's not a problem. So we got one slide to go. That would be this one. This is an example involving scale factor. It says determine whether the triangles shown are similar. If so, write a similarity statement and a scale factor. Explain your reasoning. Now, the explain your reasoning part, what that is saying is you need to list the angle pairs as congruent statements, and you need to show that the proportion is true. So we'll start with the angles because that's the easy part. According to the markings in the picture, angle N is congruent to angle R because they each are marked with one arc. Angle Q is congruent to angle S because they're each marked with 2 arcs. And angle P is congruent to angle T because they're each marked with 3 arcs. Now, it is technically possible that in a problem like this, I could make you identify things like vertical angles, alternate interior, corresponding, the same sort of stuff we had to do when we did this with congruence. But in this case, there's nothing to it. They're all marked. So we can just state the 3 sets of angles. The harder part is that we also have to check the proportion. So based on these congruent statements, we would have to say NQ is to RS as QP is to ST as NP is to RT. Now, how did I get those? NQ are the first 2, RS are the first 2. QP are the second and third, ST are the second and third. N and P are the first and last, RT are the first and last. Now we have to check that proportion. So we're putting question marks in there because we have to make sure that that proportion is true. Okay? So what we do is we plug all of the side lengths in. NQ is 12.5. RS is 10. QP is 11.5. ST is 9.2. NP is 15. RT is 12. Now we have to check and make sure that these 3 ratios are equal, that they're the same. That is as simple as dividing. Put them in the calculator. Okay? When we divide 12.5 by 10, we get 1.25. When we divide 11.5 by 9.2, we get 1.25. When we divide 15 by 12, we get 1.25. So all 3 of those ratios are equal to 1.25. What that means is that the proportion is true. So at this point, what we've shown is we've shown all the angle pairs are congruent, and we've shown that all the sides are proportional. Now, the one thing we don't have right now is a scale factor. Only we do. The scale factor is 1.25 converted to a fraction 5:4. Now, on your calculators, you all have the school calculators or an equally impressive calculator. If you have 1.25 on your calculator and you hit the button above enter, the double arrows, that will convert that decimal into a fraction. And the fraction version of that decimal, that's your scale factor. So this question we would say, yes, triangle NQP is similar to triangle. Now, when we name the second triangle, it has to match up. So since we did N first, R has to come first. Since we did Q second, S has to come second. Since we did P last, T has to come last. So we'd say yes, then we write our similarity statement. And then we'd say with a scale factor of 5:4. That answers all parts of the question. We've shown our work, which explains the reasoning behind our answer. And we should be good to go. Okay. So, at this point, we have finished the lesson.